All right, guys, Mr. Jenkins here. I was going to work through the quiz that I had you take today. We weren't using it as a quiz. Remember, we're just using it as a review, but just to follow up with you guys and basically so we don't have to spend more time on this Monday than we need to, I'm going to go ahead and send this out ahead of time. So on that note, we will get right to it. Okay. So number one, f of x is shown, da 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 da. So on number one, we want to type the number of discontinuities. All right, so we can tell that by working on our graphing calculator. So I'm going to type the function in just like I see it, x squared plus 2x minus 15, close parentheses. Notice I do put that in parentheses. And then divided by parentheses x cubed, that'd be x caret key 3, then plus 7x squared, and plus 10x. 10x. All right. So now I could look at the graph, but I'm gonna go look at the table. So second graph, and basically I'm looking for anything that has an error as being a discontinuity. So you do have to kind of be careful here because you know, they're not all on the screen. But in this case, I know there are 3 because I see an error at -5, at -2, and 0. But you could see how using this method you might miss one if, say, we had a discontinuity where x equals 20. Would you arrow that far, right? So we'll get into how to tell without a calculator in a later example. All right, so it has 3 total discontinuities. So, and again, that was anywhere where we got an error as an output, right? So those are 3 values for x that that don't work. Okay. And I don't see number 2. There it is. Okay, I just put that up too far. All right, so number 2, does f of x have any vertical asymptotes? So on this one, you can still tell kind of from the graph if we actually look at our graph, which my window is funky, so let me change that. Generally, I go to 10 by 10, so -10 minimum, and maximum, -10 minimum, 10 maximum. Sometimes you have to play around with that. So anyways, this will be kind of the picture we want to see. So it's kind of you know, tough to tell you know, what exactly it is. So I thought we might be able to tell by looking. So anyway, since we can't tell exactly where the asymptotes are, now let's get into factoring out this expression. Okay, so when we factor the top, you'd get x plus 5 times x minus 2. And then your denominator, we'd factor out an x. And then we'd have x squared plus 7x plus 10. So that would factor out to x plus 5 times x plus 2. And now you see kind of down low to the discontinuities question, we have 1, 2, 3 separate factors containing variables, so it makes sense that we would have 3 discontinuities algebraically. So now vertical asymptotes. Those are any discontinuity that basically don't cancel out, right? So don't reduce. So since that reduces, right, I'm just looking at, for vertical asymptotes, I'm looking at this factor and this factor. And that is anywhere I would basically set that equal to 0. So for the left-hand one, for x, we just get x equals 0. And for the other one, x plus 2 equals 0 gives me that x also can't be -2. All right, and if we went back to our table, we would see that that's where 2 of the 3 errors were, where x equals 0 and -2. All right, so any holes, that would be the discontinuity. I think MathXL called it a removable discontinuity. So basically, also we would say if it cancels out. So this is the one I'm looking at for a hole. So x plus 5 equals 0 gives me that I have a hole at x equals -5. All right, so that's the difference between a vertical asymptote and a hole. Now, if we kind of look at our graph, let's see if it makes a little bit more sense. So vertical asymptotes at 0, so looking at the y-axis, that is an asymptote. We could see, you know, how it kind of acts like one there, and then -2. All right, we can kind of see where x is 2 looks like an asymptote as well. You can't really see the hole on the graph there. Okay. All right, so does f of x have any horizontal asymptotes? This is where you would just need your notes. So this is the thing where we have 3 cases where we're looking at the degree. So this is the case where the degree of our numerator is less than the degree of our denominator. So in that case, the answer is automatically y equals 0. All right, y equals 0 is our horizontal asymptote. And we see that nothing crosses y equals 0, which is also known as the x-axis when we're looking at our graph of the function. All right, does it have any y-intercepts? So kind of thinking about that, if the y-axis is an asymptote, then it should never cross the y-axis, right? So you could figure this algebraically. Remember, a y-intercept is where you plug in 0 for x. And I guess if you did that, you would get an error because you'd end up with 0 on the bottom. So I guess if you did it algebraically, you'd come up with an error there too. So answer is none here. And then which graph? So just kind of matching what I see over there with what I see over here, basically. So we're looking at our answer here should be A. So we have just kind of visually matching it up in this case. Okay. So those were the answers for the first one. Now let's go through the second one, which is already factored for us, which makes it part of it easier, but part of it also a little bit tougher. So a lot of people were struggling today with how do I type this in. So let's look at that first. And then go from there. All right, so if I have multiple factors and a numerator or a denominator, basically what I need to do is group those in parentheses. All right, so you need to, when you actually start typing the numerator, you need to start out with not just a parenthesis, but 2 of them. All right, so then x plus 2, close parenthesis, open new one, then x minus 1, close parenthesis, open new one, and then x plus 4. Now I'm going to close both sets of parentheses because I'm done typing my numerator. And now fraction bar is divided by, and we'll do the same thing here. Open with a double parentheses, and then x minus 2, close, open, then x plus 1, close, open, and then x plus 4. And then you can close them at the end or not. Your calculator does that automatically if you don't. All right. So based on what I said last time, we should see vertical asymptotes. Or sorry, let's start with the first question. How many discontinuities? So we see 1, 2, 3 factors that all contain a variable. So again, there should be 3 discontinuities in this case. So we can see that if we look at the table, maybe. So should have a discontinuity at x equals 2, x equals -1, and -4. So let's go verify that. So -4, -1, and then we set it 2. We can see those all have errors, so that's good. That kind of confirms what we thought. And now a vertical asymptote is one that's left after we cancel common factors. So x minus, or I guess the only thing that's going to factor or reduce is x plus 4 over x plus 4. So these two right here would represent my factors that give me my vertical asymptotes. So that would be x equals 2 and -1. 2 and -1. any holes. So that would go with the part that canceled. That's the removable discontinuity, also known as. And so that would be x equals -4. Number 11, any horizontal asymptote. Again, I would refer straight to my notes on this one, but degree of both of them are third degree, right? If we multiply it out, we'd get an x cubed term. I know that because I see, 3 x's on both of them. So if the degree of each one are equal, and now this gets a little bit tricky here, you do lead coefficient over lead coefficient. All right, so really what I did here is I didn't take the time to actually multiply them out. But what I did look at were all my coefficients of x, right? So 1x, 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 right? When I get done multiplying, I know my lead term is going to be 1x cubed. All right, same thing on the bottom. 1x, 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 right? So I'm going to end up with x cubed something over x cubed something. So if you do lead coefficient over lead coefficient, we get a horizontal asymptote at y equals 1. So it's a lot tougher to come up with those horizontal asymptotes than the vertical ones, in my opinion. All right, the y-intercept. All right, you might just take a quick look at the graph and just see if it appears to cross the y-axis. And it does there. Okay, so now how do we get that? Well, you could look at your table and look for where x equals 0, what's y. You can also do it algebraically. If you plug in, if you plug in 0 for x, okay, basically what we would end up with is, sorry, trying to show this, 2 times -1 times 4 over -2 times 1 times 4. So that would give me then, that's not right, what I do there. Yeah, that is right. So the 4's cancel, and then we have -2 over -2, which would just be 1. And we see that it appears to cross at where y equals 1. All right. So where x is 0, y is 1. So that's 0, 1. And remember, if what I just showed didn't make sense algebraically, we could have just looked in our table. If we understand that we need to look for where x is 0, it tells us that y is 1. Okay. Does g of x have any x-intercepts? So let's look at our visual first. Does it cross the x-axis? It appears to a couple times. So how we get that algebraically would be you plug in 0 for g of x, all right, and then basically you'd be left with 0 equals x plus 2 times x minus 1 times x plus 4, or we could just go ahead and cancel that x plus 4 since it cancels, because that's going to be removable. So that would give you that x equals -2, sorry, x equals -2 and x equals 1. So we can see on our graph that appears to match up. It appears to cross the graph at -2, 0 and 1, 0. So -2, 0 and 1, 0. All right, and then the last one, just match up our graphs. It looks like it's definitely going to be, kind of between A or C, but upon I guess further inspection, our choice ends up being C. Okay, so that's the one where all of our attributes match up. So, anyways, hope this video was helpful. You can ask questions about this on Monday, but I wanted to follow up on that review you did today in case you had any questions. Again, it was not for a grade. But I think I liked some of the discussion I heard today, so hopefully you guys feel like you got something out of it. And we'll do the study guide on Monday. Thanks, guys. Have a great weekend.